Before I actually start, I want to dedicate this presentation to my dog who passed away yesterday. I'm not a sentimental person, but I lost count of the times that before I walk at an event, I used to take my dog on a walk and be inspired and get ideas. So this talk is for Ike. So this talk is about Cedar. It's an open source project that we opened sourced last year. And it's really caught the imagination of a lot of developers, including myself, and so I've been around talking about it. I have been working in open source for more than I care to remember, been in tech for even more. It's my first week in Australia, so just to put it in context. All set, everyone. I don't make any assumptions when I do this talk. I want to separate authentication. Authorization. Authentication is the you are who you say you are. Authorization is based on who you are, what you can do. And when we define and when we're creating multi-user applications, within applications we need to make sure that we provide only access to those resources. We call that authorization. And so effectively it's where we determine who, the principal, do something on a resource. So basic, kind of like but it's important. Now, when I was kind of early in my career, I spent a lot of time actually doing PKI stuff, authentication stuff, SSOs, that kind of stuff. That problem, if you look at today and how we do SSO authentication, it's well solved. Yet, look at authorization, the same really can't be said. It's not as well known, well understood. And so that's the case, the actual theory of doing authorization is well understood. And over the last years, we've seen RBAC emerge. So RBAC is roles-based access control. Typically, you can think of that as a hierarchy, so your Active Directory, that kind of thing. ABAC is attribute access control. So typically, it's based on attributes that a user might have. And RBAC is relationship-based access control, which is around how the relationship between entities can govern authorization. And whilst they're all similar, one of the challenges with these is that if you look at RBAC, for example, in order to get kind of the fine-grained authorization you need within your applications, you end up creating groups, and you end up having probably thousands of groups in order to get fine-grained access control. Attributes kind of solves that problem, but then you have a very opaque system where you don't actually know how many attributes you have or who has what attributes. When we look at the kind of the problem space, at Amazon we kind of like try and work backwards from problems that we see and developers have. We saw that there were we could boil down the sort of problem into three buckets. The first one is around how easy it was to authorization within applications. The second was actually how you could then separate from actually the creation of those to then modifying them or even checking them, auditing them. And that kind of goes on with actually how you maintain those over time. Because what we saw is developers putting code. Now this is not my code, but this is illustrative. But we can all recognize this kind of thing, right? We've all probably done it. I've done it. I'll put hands up. I've done this loads of times. Where we kind of embed the authorization logic in our application. Now, frameworks have made this simpler for us. So I work a lot with Java, so Spring Security has made this really easy. But in today's modern application landscape, where you have applications that are decomposed into multiple different services, often with different languages, you can't always be sure that that framework is going to be the same across all your application entities. So as your application kind of increases in complexity, how do you make sure that you can provide consistency in how you do authorization? And so wouldn't it be great if across all our applications we could define a policy? So this is an example of a policy. And within our code, we could just make one standard call is authorized that checks against that policy. And that's it, whether it's in Java, in Rust, in Go, in Ruby, in Python, in the case of my demo that I'm going to be doing. So that'll be good, right? So of course, as developers, how hard can this be, right? So I want to see honest hands. Who here has tried to build an authorization system? Oh, you guys are honest and girls are honest. Fantastic. I know I have many times. And it's interesting when I've done this talk before, it's always interesting afterwards to hear the stories, right? The things that you learn along the way. And it's not easy, right? And the reason why it's not easy is because when you look at it at a problem perspective, these are kind of broadly the kind of the three areas that you're trying to address. The first thing is actually quite complex to model access controls. There's a lot of complex mathematics involved, and it's not as easy a task in order to make sure that you can cover all your use cases. The next one is that if you're writing an authorization engine within your application, it has to be performant, because you're going to be doing this lots and lots of times, and therefore performance is one of the key attributes that your authorization tool or service or code is going to need to meet. And then finally, maybe most important, is you build this thing and you now have to trust it. And so this is the litmus test I always used to give, is that I would say, do I trust this authorization logic with my salary? Do I trust this authorization logic with my life or my house? And invariably, it's hard, right? It's hard to say, you know what, I do trust it enough. So how do we overcome that? So of course, the clue is in the talk. So we created a project called Cedar, which was launched, I think, at the Open Source Summit. So this time, actually, last year in Toronto. And Cedar is effectively, it's an open source domain-specific language around authorization that composes of a number of components. The first one is this policy language, which I'm going to dive into a bit in the next few slides. The next is actually, once you've got your policies, you defined your policies, then actually how do you use those to do something useful? How do you use it to authorize or deny access to your application resources? And then the final one, which is probably the one that's most appreciated, is that how do you then use that to make it easier for your application lifecycle to add, remove, and maintain authorizations going forward. So let's look at that now in detail. So actually, I do have the slides available for those who want it. There's a slide at the very end where you can get the copy of the slides. So authorization language, first of all. So before I kind of dive into Cedar policies, it's probably worthwhile kind of covering what policy-based authorization looks like. Are people familiar with this kind of thing? Put your hands up if you've kind of looked at it before, maybe looked at Riga or OPA or something like that. Right, okay, phew. So I work for AWS, and AWS, we've been doing this for a long, long time, where you create these policies, IAM policies, that define what you can and can't do when it comes to AWS resources, but that's infrastructure. This is something completely different. It's not related. Cedar's not related. It might look similar, but it's not at all related. But it provides a policy that has similarities in that you define a scope and allow you then to define what principals can access to what resources. And you define that in your policy. And so what policy statements all have are these three components. The first is an effect, and the effect can only be two things: permit and forbid. The next is the scope. So this is how you then refine what you want to give access to or deny access to. And then condition, this is where we actually then have the kind of the ABAC aspect of this. So the first two, the effect and the resource, can you think of as RBAC, and the condition is ABAC. All policies have to have the first two. The third one is optional. So when we look at that, this is actually what a policy looks like. Okay, there's two. Actually, apologies for the poor choice of colour there. That's my bad. So you can probably read the top one, but probably can't read the bottom one, so apologies. But the top is basically where I'm permitting a resource to a principal, and then the bottom bit is actually where I'm then providing some attributes to refine whether this resource can have access to it. Now, one of the things, when we were building this, we worked with a number of customers Because one of the things that we were asked is why are we creating this? Why aren't we just contributing to some of the other policy-based open source projects? And it came down to a couple of things, but one of them was readability. And it also influenced how we built the syntax for our policy documents. So we split these out into two components. We call the condition at the top and the head at the bottom. Sorry, the other way around, head at the top, condition at the bottom. And we did this because the feedback we got from the early folks who were using this said that it was easier for them to understand, easier for them to create, and then obviously easier for them to change going forward. So this kind of was modelled and kind of shaped by the community. But in that example, okay, one of the things that maybe you might be thinking about or questions you might have in your head is that how does this policy actually know about the application that you have, right? Because all our applications are different. And so one of the key pieces when you're using Cedar as well as other policy languages is you have to model your application components and then bring them into the Cedar authorization engine, which we'll come to in a minute, okay? And so this is where you start to define your schema, and then you can use those schemas within the actual policies themselves. So in the demo that I'm going to show, I've got a very simple photo sharing application that has photos, albums, and people. And because I define that in the schema, I can then use that within my policies so that Cedar now knows what these things are and can make intelligent choices in this. Now, this is a simple demo. The Cedar schema and the entities, which we'll see later on, are files on my computer. If you're doing this in production, you wouldn't do that. You would use a database or you'd use a managed service. We have people who are building managed services around Cedar, including AWS, but others as well. So when we look at the effect, there are only two, right? It makes it very, very simple. You're either going to allow access or deny access. I'll come to what the order is of precedence in a minute. And the scope is the 3 lines after that, okay, which is basically the principle, the action, and the resource. These again they come from your application, so you have to factor this in when you're creating them. Now, one of the things that in the examples I show, I'm using very simple names, right? But if you're doing this in your application, you would not use a username. You'd use UIDs or something that you can translate as unique entities for your groups, users, etc. And the conditional clauses are optional, but they allow you to refine. And what this allows you to do within your application, when you submit an authorization request to the Cedar authorizer, you provide additional context. The context is what's used in in this here. So, for example, you might provide context around something around the IP headers, or sorry, the HTTP headers you've got within your application. So it could be location, it could be something you put in there as part of your application. The Cedar syntax allows you to do some things. You can group things together. But one of the key things, okay, and when we compare the Cedar syntax to others, initially people think it's very restrictive, okay, and they want and they ask, if you look at the open source project and the RFCs, there's constant requests about expanding operators, doing loops and all this kind of stuff. But one of the reasons why we've deliberately not done that is one, to make the policies more readable, but secondly, to make sure that we maintain performance. And I've got a slide around that and what that means later. As we're creating policies, we can actually group them into useful kind of groupings, and so we support namespaces. And so this is at a very high level. This is kind of like what a policy. I'm going to share a resource later where you can actually go online and actually start to see and play in a policy playground. So that's a kind of a quick overview of what a Cedar policy looks like. And we use these policies in order to create, or in order to, for our applications to get an authorization decision. And so this is kind of how it works, right? We have our Cedar policy as an input. We have our application stuff, so the entities and the schema that describes what our application looks like, so that Cedar policies can make sense of it. And then we have optionally context, okay, where we might put in things like HTTP headers, IP addresses, location, that kind of thing. And they all get submitted as a request into the authorization engine, which is built on Rust. And then only 3 outputs, okay, will occur, even though there's only 2 there, right? So you'll get either an allow or a deny. The third one is an error message, okay? So if something goes wrong, then you'll get an error message that comes back. So how does Cedar evaluate these requests? So the default in Cedar is always deny. So if you don't have a policy that matches, you won't get access to any resources. And it builds up from there. And denies, forbids, will always override allows. So if you have something within a policy that denies you, even if you've got explicit allow access, you won't have access to that resource. So around this time now, people are probably thinking, well, how do we actually know this works, right? How do you build trust into an authorization engine? Because we already know it's one of the key things when building these, right? And this, for me, is a new area that I had not really heard about until last year when I was looking at this. And it's super interesting. And I know yesterday there were some talks in kind of similar fields. And so what we did is we have a very large formal reasoning team within Amazon in our research team. And so they used a lot of their techniques in actually building this. And they created this new kind of process called verification guided development. And what it means is that we, and I've actually just literally changed the slides today because we initially done this in Daphne and we've recently changed to Lean. Both do similar things, right? Where we initially model our specification for authorization in Lean. And the reason why we do that is because Lean has got tools that allow us to prove correctness and security. And so we can create a semi-performant binary of our authorization engine using Lean. And then we can test it with policies and we can get a satisfaction of a proof of correctness that we're meeting the specification. Now, whilst that's good, we can't ever run that in production. Again, one of the other characteristics of running this at scale is it has to be performant. And so what we do is we create a new version in Rust. So we now have a version that's written in Lean with the tooling to prove correctness and security. We have a Rust version. And then what we do is we basically run parallel tests. And this is called differential testing. And we do this, I'm not sure what's happened to the slide there. There we go. We do this literally hundreds of millions of times. And the idea behind this at a very high level is that from the same set of inputs, so the same set of application contexts, entities, and policies, if we run it through the Lean model, we'll get an outcome. So allow or forbid or permit. And we should get exactly the same output when we run it through the Rust. If we don't, we know we've identified a bug. And that happened, okay? So when we were doing this, we realized that the code we were creating in Rust was not generating the same output as the Lean stuff, which meant that even though we thought the code in Rust was okay, there was obviously edge cases where the Rust code was generating incorrect authorization decisions. And so we do that process over and over again. And once we get to a situation where there are no differences, we know we've got a good Rust code. And we do that every new version of the Cedar. And we don't actually release it until it's passed all those tests. Now, I think it's really super interesting. It's a new area that, for me, I'd never really touched this. So that we have actually written, and this is, I think, last week, a post on actually how this works at a very low level detail. It looks at why, for example, we're using Lean. So Lean is interesting because it has this concept of trusted compute modules, I think they're called, TCBs, and they're open source, which means that you don't have to do all your proofs from the beginning. You can use some of the existing ones the community have created and build up from those and then contribute the ones you've got back. So it's kind of a really interesting shift from Daphne, which is also open source, to Lean. So that's kind of the authorization engine, but kind of the next piece of Cedar is really actually how you can use it once you've got your applications written in Lean to do some really cool things, such as making sure that you are not giving users too much access, or if you're trying to move or migrate or simplify policies for your applications, that you don't accidentally cut people off. So there are tools, there's a CLI tool, which actually is the next slide. So I don't expect you to memorize this, but I'm just putting there's a whole bunch of CLI tools which allow you to then now automate the process of checking these. And what we're seeing, and as I have a link to a resource, people are now beginning to have authorization as code. They're implementing it into their CI/CD, it's easy for me to say, CI/CD systems, and they're now automating that process, right? And of course, the key thing here is you're no longer having to worry about making changes to your code, right? So we've separated the authorization from the code, which means they can run at completely different levels, but they're still going through an automated build process. Right, so I'm going to go through a small demo now, just to try and hopefully explain this in more detail. So I have a very simple Flask app. It's a photo sharing app that has a very simple set of users, principals. We have a couple of folk in the Doe family who create photos. We have an admin, we have Joe Public. And, this might be something, that you might want to model if you had an application like this. You might want to have certain people have access to public groups. Only people from the family have access to the family group. You might have admins that only have access to admin function, etc. So we can do that, and we've modelled the application. And again, all this code is available. And so what's going to happen is that as we go through the demo, the application is going to bring in the context. In this instance, I've got no context. I'm not using that, but I'm bringing in the application entities, so the photo app, and I'll show you what that looks like. Together with my Cedar policy, I'm going to submit it to the authorization engine. So even though I'm running on Python, it's actually running Rust under the covers. So I have the Rust authorizer running. And then it's going to give me a decision, yes or no, and that's going to be reflected in the application. And so all the code I put on a repo, which you can all access. So let's get out of slideware. So I have actually, first of all, I did try, it's a bit difficult for me to navigate because it's so big, but can you see it well enough at the back? Is that all right? I know it's small at the back, but hopefully you'll kind of get an idea. So the key things here in the application, right? So actually, let me show you first of all what the entities look like. So this is like, these are static files. If I was doing this for real, I wouldn't have them on a file. I would generate these within my application. So this is kind of like the sample data I've got. This is my schema. So this is what the application looks like. I've got a photo app that has users, user groups, photos, albums. I have actions, so I can view a photo, I can manage a photo, and I can also do a site admin, okay, and who these apply to. So this is kind of the underlying language now that Cedar policies will understand when I'm creating my application. And my sample policy, where is it? Where is policy? Is it this one? Yes, it's this one. So at the moment they're all grayed out. Okay, so so the idea being is I'm going to start building up from no access. So when I try this application, no one should be able to do anything, and then slowly build up, and hopefully, if the demo gods are kind, it will work. Now, I've chosen Flask deliberately because it's a very simple and it gets out of the way of showing. But within Flask, you define routes. You can define routes that have to be authenticated. And then once they're authenticated, we can then define whether someone is allowed to access or not. So here is, for example, the admin route. And if I get that out of the way, so let's see if I can move this. We can see that I'm reading in my policy, and then all I'm doing is making a call is authorized. And I'm putting in the policy, the application entities, and the schema. The other bits are optional, and all I'm doing is I'm checking to see the result. If I get a deny result, I display the deny HTML, and if I don't get that, I permitted, I can then basically go through. So that's simple, and I have to do that. I only have to call that for every single route within my application. So the application might have been created differently if I hadn't done this. I would have had to go through and cycle the different groups and then define and determine who had access based on. So my logic will be different for every route. So this simplifies everything. So if I show what this looks like, so hopefully, so before I do that, this is the repo. I've got instructions on how to run it, so you should be able to do it. And I mentioned that you can actually play around online with this. This is the policy playground, which provides an online kind of way of kind of like getting hands-on with this without having to deploy anything. So this is my application. If I try and do anything, it's going to ask me to log in, right? And I'm not going to have any access. Now I have got some users. So let's try. So the users here are, because it's a super secure application, right? Because I'm really good at doing authorization engines. I've got a text file with my user and password information. So I've got admin access now. So in theory, I should be able to go to admin page, but no, I'm not allowed to do anything. And the reason for that is because my policy, okay, is currently empty. So we've proved the first characteristic, which is if we don't have anything in there, Cedar will just block everything. So I'm going to start off with Joe Public. Let's actually make sure that, because I always get this name wrong. Yeah, it is actually Joe Public, okay. So let's log in as Joe Public. And again, same thing, right? I can't look at anything. So what I'm going to do is I'm now going to just enable save. So what I've done is I've now basically allowed this policy, which basically says that if I'm user Joe Public, I can access the view photo action on the public photos of this photo album. Now I'm running VS Code, and there is a extension that is available that allows you to make it easier to do syntax checking. So if I made a mistake in here, for example, if there's no action, if I do, for example, that, you'll see it comes as an error, and basically it's the plugin basically saying it's unrecognized. I always recommend, if people are interested in experimenting with Cedar and you're using VS Code, there are the same team. Well, she's not the same team. It's a separate team that from the Cedar team, but we're using a lot internally in Amazon. They've created these tools to help developers work and create policies. So now, if we refresh, no, not refresh. Actually, we don't need to refresh. If we click on public photos, this should work, right? Yes. So now Joe Public can actually see that, and all we've done is change the policy. So let's log out. So the next policy, okay, is what about if we wanted to make the does be able to view their photo? So let's have a look at what they can do at the moment. So let's log in as Jane Doe. And at the moment, they can't do anything either, right? So if we change the policy, oh, get away. Okay, and we can now look at public photos, we can look at my photos, but we can't yet manage photos. And that's because there's a separate permission for that, which we can now enable, and now I can do that. So you kind of get the idea, and we have a similar policy for admin that would allow the same thing to do. So this is a very simple example of how you can use Cedar in Python applications to do authorization. Now, we have Rust and Java libraries that we produce, the Cedar project produce. This is a community-created library. There's also one in Go that's created by StrongDM, and there's also a community one created in Ruby. So there's a number of languages that you can run. We also have some partners that allow you to, or created sidecars. So if you're running containerized applications and you're using other languages like, for example, TypeScript or Node, you can then make a call to that local sidecar the same kind of way. So that's the demo. Quite a quick demo, but hopefully it kind of helps explain a little bit more in detail. Now, this was published, I think, about a month ago. There was a research paper. I mentioned that, one of the things that when we were building this, we were really keen to make sure was that not only that we could prove correctness and security, that we could also make sure that it was secure, fast and performant. And so this research paper shows the performance at high load of Cedar for doing authorization requests. One of the interesting questions that I often get is that as your application gets really, really big, say if you've got millions of entities in your application, how does Cedar scale? And Cedar has this concept of slicing policy. So within the code, it will take the policies and entities, and it will only take a subset of that information, so that it's not taking the whole amount. And the slicing is done in a way based on the schema and the entities, and it's done in a way that doesn't miss any important data. And again, that's been run through the lean tools to prove correctness. But the reason why this research was done is to make sure that we could give confidence to people who wanted to do this at scale, that it's not going to be a bottleneck in your system. And there's also, like I said, people are beginning to now build this into CI/CD systems. So we're now seeing authorization policies being checked in and then automated as a way of managing your authorization to your applications, which is a very cool way of doing it, because you can apply all the tests. So within the Cedar CLI, you can run tests, verification tests. And if, for example, your authorization rules don't meet your tests, you can basically stop the deployment because you've broken one of your access control rules. So if you are wanting to get more or take your first steps in Cedar, we have an online, the thing I showed you, the policy, anyone can just go onto that and learn about it, as well as do hands-on. So it's a little bit limited, but it gives you enough to experiment. There's also, it's an open source project. It's just over a year old. It's a growing community of authorization nerds. And the project is actively being developed. So there are RFCs all the time, changing and shaping the direction of what is supported and how it works. And we also have a more comprehensive workshop, which you can run. So that's actually my talk. I've been quite quick, but that's because it's, I don't want to kind of labour the point. So to summarise, Cedar is this open source authorization policy language and authorization engine which you can build into your applications today to kind of get started. We do have a managed service of it, and others now are building managed services. So Permit.io, one of our partners, who allow you to build. Sorry, was that me? Okay. So that if you don't want to manage your Cedar policies or your entities, you can do that through some of these managed services. But at least I'm an open source person, so I prefer to start off with the stuff here, get a better understanding of it, and then decide what I want to do afterwards. So I think I've got plenty of time for questions if people are curious and want to know more.
Yeah, we've got 10 minutes for questions.
Thank you for your presentation. You mentioned a bunch of libraries that have support already. Are they invoking or binding to the Rust implementation or some official implementation, or are they implementing their own policy engine for the language?
So they are binding. So Java uses Java bindings. Python uses FFI. So the problem is that if you build something, let's say in Go, you can't prove it's correct unless you go through the verification process, right? So we don't currently have anything other than Rust going through that process and Java going through. Sorry. We don't have anything other than Rust going through the design verification testing. The Java stuff we produce is just using under the covers the Rust.
Oh, I've just got a bit of a follow-on. Like, so if my favourite language is not represented in that list so far, do you have documentation on like how to do, say, a CFFI binding? Like, or would I just need to look at, say, an existing one, like you said, Python uses FFI?
So the examples in the Cedar repo cover Java. The Cedar one, the Python one I'm using, shows you how to do that for Python. But what we're seeing is that we released a thing called, it's called the agent, what's it called? I can't remember what it's called now. It was released about 3 months ago, and basically it's a sidecar you can run. So it's still running Rust, but you can effectively, with your, if you prefer to use your favorite programming language and don't want to do bindings, you can make local calls to that and still get your authorization requests. So that's another pattern that we're seeing a lot of people do. And this is where Permit.io have got basically a really nice UI that make it really simple for you to do this. Whether you run it and want to run it self-managed or in their cloud service.
So I was thinking more like if I wanted to have in process as a library in your application.
Okay.
Sorry, I was thinking more like having it in process in a larger application to provide the authorization service inside that application. So I'm guessing it's like it's fine to use it multi-threaded and so forth via the FFI. As a C library, I guess.
Yeah, I mean, even we have people even within their application code, right? So in my example, right, I'm doing an in-process call, right? But we have people who are making external calls, and it's still performant. Okay, it's sort of it's very low latency. So the architecture design. So actually, if you use so AWS has a thing called AVP, Amazon Verified Permissions, and that's using a Lambda function to do this. And it supports all the other programming languages, but it's still a call. But we feel sufficiently confident that the performance is good enough that no one's going to notice, because if they did, then they would shout.
So you mentioned that obviously these schemas and entities and everything have to be formally modelled. Is being able to go from your application code into those schemas and entities something that Cedar provides out of the box, or is the intention that people will bring their own code to be able to keep those in sync?
So you have to bring that. Unless you're using one of the managed services, and then the managed services will do that for you. And the managed services all do it differently. And I guess that's their value add, right? Because knowing how to model your application in a way that the Cedar policy you can use in your Cedar policies, you can do that as a developer, but you might want to offhand that to something else, right? So the stuff I've showed you doesn't help you at all with that. And we suspect that probably that's where people are going to spring up to offer services in that and to support that.
Thank you. Got any further questions?
Me again. You mentioned the slicing and that it assists performance, but how does it enable distributed evaluation of the policies? It just wasn't clear how slicing contributes.
Yeah, so the way that it works is that if you take your policies, typically a policy will only work on a subset of the entities and the schema, right? So what the Cedar does is it actually builds a tree, and then from that understands which portion of the tree is needed. That's a simplified version of how it was explained to me, because I also had I was doubtful as that, if you had millions and millions of objects, how this would scale. And I was explained that don't think of it as a flat model. Think of it as the Cedar will create a tree hierarchy, similar to like how OpenSearch does search indexes. The reverse tree. It does something similar. So you're only working on a subset of the data. The question then you might have is, well, how do you know it's the right set of data? That's what Cedar's spec has created, they do that through the tests to make sure that there's no situation where information is missing from the authorization request. So that's how it's been explained to me. I kind of understand it. It's kind of like the magic that their algorithm knows what portion of the schema and the entities to use. The policies themselves tend to be not that large. And also one thing I didn't mention is that you don't have to have one policy document. You can have one or hundreds of policy documents, right? So that's the other thing. Breaking them down into different policy documents can help as well.
I'm wondering, is the policy entirely in the language that you've been using, or can you have dynamic policies that are instantiated by an administrator at runtime?
So the policies, I mean, I showed you a static file, right? They can be in memory. You can construct them from a database. We also have things called policy templates where you can actually put placeholders, although currently the only thing you can template are, I think, resources and principles. So this is something that's being discussed very heavily in the actual open source project. But like I said, I've done it for simplicity, but I could have architected the policy. The challenge you have, okay, is when you think about the characteristics of authorization and what problem you're trying to solve, you want to make sure that this is transparent to your users, right? You don't want to bury this in something that needs a developer to change, right? So I would argue that if you put it in your code, is that the right thing to do? Unless you're surfacing that up somewhere that makes it like persist to a database and they can view it and change it that way. So just be very careful, because obviously one of the things that this is intended to is to make authorization decoupled from your application logic. You don't want to then go against that, right?
Thank you very much for your talk, and we've got a little gift.
Thank you very much.
As a thank you for the presenters.
Thanks.